Hello students, in this video we will discuss a problem based on gravitation. So we have to match the following column. Let us start with option A. The sum of potential and kinetic energies of a missile launched with a speed of 3 km per second is. Now since we know that this speed is less than escape velocity for Earth, which is approximately 11 km per second, so we can say that, or we can conclude that this system of satellite plus Earth is a kind of bounded system. And we know that for a bounded system, the total energy of a bounded system is negative. So we can say that option A matches with Q. Now let us shift our focus to the statement B. Kepler's second law states that the straight line joining the planet to the sun sweeps out equal areas in equal times. Now this statement is equivalent to stating that, now we know that Kepler's second law in terms of equation can be written as aerial velocity, that is dA by dt, is equal to L by 2m, where L is the angular momentum of planet with respect to the sun. Now since this term remains constant, therefore we can conclude that angular velocity remains constant. So from here we can say that the Kepler's second law can be equated to option P, that is angular momentum remains constant. So our correct option will be P. Now for statement C, a planet revolves in an elliptical orbit around the sun. The semi-major and minor axes are A and B. Now its time period is given as, now according to Kepler's law, we know that t square is proportional to, that is time period square is proportional to the cube of semi-major axis of the elliptical path. So we can match this option with option R, where A is the semi-major axis of elliptical path. Now for option D, for statement D, the ratio of time period, the ratio of time period of geosynchronous satellite revolving at a height of 6 hours above the Earth's surface to a satellite going very close to the surface of Earth will be, we know that t square, the value of t square is proportional to, the value of t square is proportional to r cube. So we can write the ratio of time periods to be equal to since for this geosynchronous satellite it is orbiting at a height of 6 hours, which means that its radius of its orbit will be equal to 7 hours, that is 6 hours plus r is the radius of its orbit. Let me write small r over here in order to avoid confusion. This small r is radius of the orbit. Now comparing it with a satellite which is going very close to the surface of Earth, we can say that for such a satellite orbital radius will be roughly equal to capital R. Now from here we can write the value of t1 by t2 will be equal to 7 root of 7. So this will match with option T. So this is our final desired answer. Thank you.